present the Viatra solution now. Basically, Viatra is not based directly on EMF, so we have a separate file called model space that contains a copy of various models that Viatra uses to represent the world. Here is everything that comes from EMF, apart from eCore. Here are the E packages, the various EMF meta models imported. And we have imported this graph instance model here. Now there are all these transformation scripts here, so we select one at random. There's a script description, we'll get to this back later. And if we run it, oh, did I run it? Oh, yeah, parse it and run it, yes. Then basically it logs some stuff here. So we print some stuff here, it's just a log. This is a system log here, not very important. The important part is that here in the model space, there are now various additional instance models. These are the various greeting results, and now if I want, I can export them as EMF files, so I can examine or something. Okay, so basically that's how one uses Viatra, and probably we won't have time to review each of the solutions because we won't have time to understand them if I rush through them. So let's see the insertion of transitive edges. This is the solution code. Here there's this graph pattern edge from 2, which says that in the graph there's an edge whose source is from and whose target is the node 2. Now obviously these two lines are really the only things that are required, that the edge source is from, that the edge target is 2, but we are very scrupulous and we also check that there's a graph and this is an edge of the graph and this is a node in the graph and so on and so on. You could say that this is not really required to check and where the solution would work without it, but it's also not a big hurdle to write it, because if you open the model you can just say that here's the graph and I need 2 of the nodes and I need 1 of the edges, so you just select some elements from the graph and then you can basically copy those elements and then paste them as a pattern. So it really doesn't take a lot of time to write something like that. So we have a pattern that expresses that 2 nodes are connected in the graph. And this is another graph pattern saying that from is connected to inner and then inner is connected to 2, but there's no direct connection from to 2. So basically this is the pattern that expresses that the transitive edge is missing from to 2. And then we have a graph transformation rule which just says that there's this, the left hand side is this transitive edge missing, and the right hand side is that we complete this edge from to 2. And of course you can solve the same a little bit more imperatively if you want to. So you can, just for the single match of this left-hand side pattern, you can, for each of the matches of the left-hand side pattern, you can imperatively create all the edges and connect them into the graph. But of course, in this case it takes a little more space. Sometimes it's more concise to use the imperative form. And of course, what some people complain about, which is the quickest solution, here we have basically, this is the solution of the case study. So we apply this GT rule for all of its application places, but so all the matches. But we can also submit a different solution, which only differs in one line, which says we iteratively apply it as long as we can, and then obviously you can see it will complete the whole transitive closure. And actually, the nice thing in Viatra that you can do it in one step. So basically, you can do it with one GT rule if the missing transitive edge is a little bit different. It uses a transitive connected pattern, because in the pattern language you can recursively express that what is transitively connected in the graph. So, and I think my basic time is up, the basic 5 minutes, and I have 1 more minute to respond to the reviewers' comments. Basically, the main negativism that was brought up is that some things are a little bit too verbose to express. So even in the HelloWorld case study, if we want to set a simple attribute, okay, probably not the GT version, probably ASM version would be easier to explain. So if you only want to set a single attribute, we have to do a lot of model manipulations, because VPM is a graph-like representation, so we have to create a node for the attribute value, set the value to the string, and then create an edge that connects this node from the object node, as opposed to an object-oriented formalism where you just set an attribute to the value and that's it. So yes, this is one of the drawbacks of using a graph-based formalism. And the criticism is right. Of course, you can possibly refactor this thing in a utility method that takes a parameter for the edge type and the parameter for the value of the node and the parameter for the attribute type. And we actually have some sort of EMF utility methods like that stashed away somewhere. But the core language doesn't support this very concisely, so this is a valid criticism.